Right, today on the bench is the valve tester, homemade valve tester that I built some time ago, and I put it down because I was a bit fed up with it. I think I made a few mistakes on it. Namely, I tried switching like the HT bias and everything on and off by switching the ground. That didn't work very well, so I'm going to change that. The screen grid supply wasn't very brilliant. It kept blowing kept blowing fuses. So what I'm going to do, I'm going to keep the valve regulated power supply for the screen grid, and then I'm going to use this I'm going to use this nifty little variac, a bridge rectifier, a couple of caps for the anode supply. This is capable of 500 milliamps, so that should do the job, and that should go there. And then apart from that, I mean, it's done. I've just got to sort out, where I'm switching the, the ground and everything. And I think there's maybe a little bit of work needs doing on the heater supply, maybe. And what else? Oh yes, I need to build the Felpham valve tester so I can test GM. So that will need building at some point. So hopefully this shouldn't take long. Just got to bung the variac in. What I should do, I should still use the mains transformer, for its isolation, and then connect the variac after the transformer for the anode power supply. More later. There's the variac secured in there. I've just got it wired to my variac at the moment. I'll jiggle you over this way. Can never be quite sure whether you can see that. I think you can. So that's maximum. You can see it got quite fine resolution on it. Settles at about 2.4, so that should do us for our anode. And like I say, we'll use the valve regulated power supply for the screen grid. Job done. There we are, sometime later. I've sorted the power supplies out on the valve tester, and to really put it through the paces, I am testing a 6528 dual 30 watt triode, big series pass devices like a 6080 on steroids. Big fuck off lovely valves. I love them. I think they just look smashing, real Bobby Dazzlers, as they used to say back in the day. So let's see what this bugger can do then. So I'm going to point you at the amplifier, and if you keep your lug holes pinned back, you will hear a lessening of the fan, like it will slow down, because it really sucks power out of the heater, and the fan is run off the heater doodahs. Right, so let's bung the heater on. Yeah, hear that? Ooh, yeah, bugger. That's sucking it, that is. 0.5, 6, 6.1, 6.2, 4, come on baby. Give you a little, now you're gonna go? Yeah, there we go. 6.3 volts at 5 amps. That's a hefty bugger, that is. Yeah, those two N3055s are getting quite warm now, so I don't want to be doing this for very long. Right, next G1 grid 1, so I want to spank that up a bit. Right, hang on. Yeah, that's probably a bit much. Right, next anode. It's got to go to 100 volts. That will drop down as I start to drop the bias voltage down. Just now we're looking, I can never tell whether you can see that one because of the glare. 40 milliamps on each one, and so I have to keep flicking backwards and forwards, keep chucking up the anode to make sure that's at 100. And let's see where we are on the grid. Just make sure all the heater's right. Yeah, back onto the grid. I'm at -7 volts, and as you can see they are about 70 milliamps each. I'm going to go all the way down to -2. Ooh, that's a little bit too much. Okay, -1.19. Okay, I need to bang that up. Oh, you fuck pig. Don't do that. Right, sorry, I turned it the wrong way. Somebody's wired the pot in the wrong way. Right, 150, so we need to go back to a HT anode voltage because it's dropped down to 84 volts. And it's back up to 100 volts. I can set it pretty bang on with just that variac, little variac. Let me just check me G2. Right, we can drop down a bit. Right, somebody's wired the bloody thing in the wrong way. -2 volts bias on the grids. Let's drop down to 96. Knock it up a bit more. Right, there we go. That's what I got last time. 245 milliamps and 246 milliamps. And I'm going to start giving it a bit more of an easy time now. Let the fan cool everything down. Yeah, so the volt tester, right, let me just pull you back. Yeah, I can smell something burning. I'm going to go and have a look-see in a minute. So this valve tester, as you saw, can test some pretty meaty valves, which is good. So the power supplies are about there. I mean, they're struggling a bit, but anything would struggle at that. That's 30 watts on the anode. Yeah. It can probably, I don't know, I think the anode could probably do more than that. Didn't test the screen grid supply. I don't know, where have I written that down? It goes from about, where the fuck? I'll tell you, it goes from about 180 volts to 355 volts, and the anode voltage can go to about 355 volts. So all the power supplies seem to be working okay. So what I need to do now is populate this board, which is for testing GM, but there is also, you can also test anode current, anode voltage, screen grid voltage as well, making my sort of switch over here a little bit superfluous. But I don't know, I'll see about that. I'm going to build it first. I'm going to build this first and test it, and then we'll take it from there. And then also we can, if we want, add a gas test and a heater cathode short test, and that's just using a 10 meg resistor either from the bias supply to the grid or from the heaters to ground. So I'm going to have to look into that a bit, but first I'll populate the PCB as mentioned previously. Okay, let's try again, shall we? And this time press record. Have we pressed record? Yes, we have. Good. Okay, let us proceed. Here's the PCB, Felpham PC, off a forum. If you want to know where these come from, I can put a link in there if you wish. I think he still has about 10 of these. This is the version 1. The ones he's got are version 2, because there's a mistake on here, but I'm not worried. Right, let us proceed. Over on the right hand side we have a load of headers which I shall use to mount all the op amps. We'll get to that, that's the end bit. First we're going to start with the resistors. The resistors, these ones, this one I'm sort of flicking about here, will go here on this stage here, and they form a potential divider so that the voltage seen by what voltage is seen by which, I should know, shouldn't I? I've just read the bleeding thing. Anyway, the voltage out of this goes into an op amp. Can't remember which one. It might be U1. I could be wrong. And they require not R1, that's 100R, R2 to R7, and R something or other to R14 are all 390k matched. Helps if they're matched. High voltage resistors, nearly said transistors, resistors. The chap who designed this originally, I think, was Peter. Sure it was. Yes, PT, yeah, electron pusher. Used 2 watt 390k because that's what it had. Hence the big footprint. However, John, down in our man in Somerset, in Wincanton in Somerset, kindly sent me a load of high voltage. See the blue? Blue usually means high voltage. Match 390k resistors, I think. Bless him. Thank you, John. So the first thing I'm going to do is bungle them in and solder them in. I won't film that because it's as boring as. There we go. That's R7 to... let's start again. That's R2 to R7. They've not gone in too bad, although one, I mean they're absolutely fine, but I'm just trying to make it, need a bit more solder there, a bit more solder on that one. I mean they're fine as they are, but let's do the job right. So what I did, as you can see, I got a load there ready to go in. So I've got, it's just like a tapered bit of wood. I make them when I get bored. If I find some nice wood, I get my knife out and whistle. So I just got a mark there, which is a little bit up. Oh, it's better doing it around the camera. You get the idea. Whoop. Whoop. Oh, where's the other buggers gone? Right, there we go. Try and make them all nice and neat. All the same. We're trying to emulate tech. I mean, it's easy, we could just whack them all in, but that's not the it's not the job there. I think I've lost one. I'll go and retrieve that in a minute. So I'll just pop you back there. Right, so next we need 14 to 16. Right, that one's just jumped off the bench. Swine. 14 to 16. Where are we? What? Oh, it's over here. Oh, right. Right, and I'm making, because these are, right, what's that? Brown. These are 1% jobbies. Oh, I can't see a damn fucking thing, can you? Pop them in there. 14. Oh, I keep forgetting, my head is a shed. 16, you peanut. 14 to 16. Right, you're all happy in there, lads? We are. Bit of what's it? Tape. what's the fucking stuff called? Frog tape. Pop in there, stop the buggers jumping out. Right, where are we? Here. It's hard to see them unless you do that. See? Right, so we're going over here. Just gonna fettle them. There we go. Right. Thanks Mike the Bike for the iron. Mike the Bike sent me this. I'm going to show you some other bits in a minute. Apropos or nothing. He's a good old boy. He just really looks after me. Because my iron, as you saw from one of the videos previously, buggered off. So where are we? Bit of solder on the iron, get the bugger wet. A little bit too much there. Yeah, that's grand. Onto the pad. Bit of dwell time. I think I was a little bit, we need a little bit more looking from those other ones, so a little bit on that. Wants to be on the lead and on the pad. There we go. They're in there nice. Cushy. Right, which ones needed doing before? We just need some of these, just tiny bit of refreshing. There we go. Oh, just a little smidgen. There's all the other lads. They're grand. They're grand. So next, take off, and you see, they ain't too bad, are they? Don't look too bad. Next, we'll get a little pot, because we always save the leads, and very useful. And just pop them off. Right, and I shall proceed thusly and see you in a little while. Here we are the next day. I was at it most of the afternoon, yesterday afternoon, but as you can see I've got most of the resistors, well just about all of them in. However, most of these like are right, that's right, there, those, there. There are a few though to do with the oscillator and a few other ones. This being a the first board that he knocked up, there's a few mistakes on it. So there's those that I've got to sort out, and also there is, what else is there? Yeah, there's a few other resistor values might change, and some capacitor values change if you use such and such a resistor. It's a bit of a maze. There's like a few revisions and all that as mentioned. Anyway, I shall go into those at the end or at some point and go once I've got my head around them. So done the resistors, put one capacitor in there, and then there's four capacitors, the 4700 picofarads or 4N7, and as you can see I've used these ceramic types. They're probably fine, but ceramic capacitors, as far as I know, right, these are coupling capacitors. Ceramic capacitors can do some weird shit. Not so much at audio frequencies, but depending on what dielectric they use, they can do weird things. So I'm going to replace them. A bit overkill really for these ones, 400 volt jobbies, but these are, you know, just your, what are they, poly something or other, some fucking plastic. So there's those to do, and yeah, Some of the I've got loads of capacitors, but it's the same old thing. Whenever you come to do a job, you've never got the fucking right ones, despite having thousands of them. So I mean, that's the case in point. So I'm going to put all the capacitors in, and then I shall try and find all the correct, what do you call it, preset pots. There we go. Right, bung the iron on, and then we'll do that. There we go. I've done one. That seems to have done all right. This one. Spoke too soon. Bung a bit more solder on that. I really ought to clamp this, but there we go. Tiny bit. Luckily, I sort of pre-saw this, as it were. I had an idea they would have to come off, so I only soldered one of the legs. Come on, yeah. Bit fiddly to get at. A bit more solder. Right, I shall continue on with that. See you in a moment. Right, here we are sometime later. As you can see, I've populated a few more capacitors, and because I haven't, I mean, I would have used either 10 ends, which I've got loads of, or 100 ends. And these are just all these big blue ones here, and these white ones, they're all 47N, and that's what Peter used as decoupling. When I do op amps and all that, I always decouple them using these little ceramic 100U caps. So on dual op amps like TL072s, the power pins are on, depending which way around this is, 4 and 8. So when I build boards, the rails are usually like that, so I can just do that. Or, right, hang on, let me get some. I've got a fag in one end. Right, I'd do something like that. Surface mount under the bottom. You with me? I know you can't fucking see, can you? You see that? Look, I'd do that right on the pins, and I was going to do that. But I think what Peter's done, and let's just check. Sprung me meter on, diode check, spinners round. Right, this is a power in here, plus VCC, minus VCC, plus minus 15 volts, ground. So see, he's got one end to ground. And then let's just check that C9 there. It ain't going there. Is he going there? Where's he going? That's going to ground, as we know. No, it isn't. Where a pack. Right, see ya. See, right, so what the fuck? That's going to there. What's that? That is, that's you too. That's a TL071. That's our GM. That's our GM single op amp. So let's choose a better thing, because I don't know where the power rails are on that. So let's choose C15, which is here. There. See? So let me just go find my ground again. Right, there's ground. Right, and then that one is going to pin 4 or 8. See? There. So what he's doing there is, instead of me having like VCC plus minus there, and having a cap across there. I think what he's done on each one is probably more correct than what I'm doing, is have a cap to ground, cap to ground, like that way. I think that's what he's doing, because I know when I was looking at the schematic doesn't show all the coupling caps on the schematic. It's just got like a thing at the bottom. So yeah, that's what he's done, I think. I tried to get all these 47 caps lined just bang on, because there's no point me trying to do all these resistors all lovely if the caps are all a bit skewed. I mean, that one's I'm not happy about that. That's just wants turning a little bit, but I mean, that's just, you know, people call it OCD. It's just trying to do a good job in my eyes. Yeah, those two, you see, they're a bit off kilter, so I'm going to turn those around a little bit, and then I think we're not far off. We've got C19, we've got to bung that one on. C23, got to bung that one on. A couple of diodes there, that's for the oscillator, I think. Or basically you've got two diodes for the precision rectifier. Sorry, that's I'm not quite sure which. Two diodes for the precision rectifier, two diodes for the wine bridge oscillator. So we've got two caps. Alright, I think we've got two caps left then, and then all the rest are our presets. Right, onwards, onwards, onwards and upwards. Right, here we are sometime later. As you can see, I've populated a few more capacitors, and because I haven't, I mean, I would have used either 10 ends, which I've got loads of, or 100 ends. And these are just all these big blue ones here, and these white ones, they're all 47N, and that's what Peter used as decoupling. When I do op amps and all that, I always decouple them using these little ceramic 100U caps. So on dual op amps like TL072s, the power pins are on, depending which way around this is, 4 and 8. So when I build boards, the rails are usually like that, so I can just do that. Or, right, hang on, let me get some. I've got a fag in one end. Right, I'd do something like that. Surface mount under the bottom. You with me? I know you can't fucking see, can you? You see that? Look, I'd do that right on the pins, and I was going to do that. But I think what Peter's done, and let's just check, spun me meter on, diode check, spinners round. Right, this is a power in here, plus VCC, minus VCC, plus minus 15 volts, ground. So see, he's got one end to ground. And then let's just check that C9 there. It ain't going there. Is he going there? Where is he going? That's going to ground, as we know. No, it isn't. Where a pack. Right, see ya. See, right, so what the fuck? That's going to there. What's that? That is, that's you too. That's a TL071. That's our GM. That's our GM single op amp. So let's choose a better thing, because I don't know where the power rails are on that. So let's choose C15, which is here. there. See? So let me just go find my ground again. Right, there's ground. Right, and then that one is going to pin 4 or 8. See? There. So what he's doing there is, instead of me having like BCC plus minus there and having a cap across there, I think what he's done on each one is probably more correct than what I'm doing, is have a cap to ground, cap to ground, like that way. I think that's what he's doing, because I know when I was looking at the schematic doesn't show all the coupling caps on the schematic. It's just got like a thing at the bottom. So yeah, that's what he's done, I think. I tried to get all these 47 caps lined just bang on, because there's no point me trying to do all these resistors all lovely if the caps are all a bit skewed. I mean, that one's I'm not happy about that. That's just wants turning a little bit, but I mean, that's just, you know, people call it OCD. It's just trying to do a good job in my eyes. Yeah, those two, you see, they're a bit off kilter, so I'm going to turn those around a little bit, and then I think we're not far off. We've got C19, we've got to bung that one on. C23, got to bung that one on. A couple of diodes, that's for the oscillator, I think. Or basically you've got 2 diodes for the precision rectifier. Sorry, that's I'm not quite sure which. 2 diodes for the precision rectifier, 2 diodes for the wine bridge oscillator. So we've got two caps. Alright, I think we've got 2 caps left then, and then all the rest are our presets. Right, onwards. Here we are in the control room, and this is the schematic of the Felpham valve test and measurement. So as you can see, here's all our 390k potential divider resistors. Basically there's 6 up here and 6 down here, and then what we've got here is a differential. This is an op amp, differential amplifier, balance, whatever. This is floating. This is where your anode sense resistor is, so there's supposed to be 100R anode sense resistor there. That comes out there. Then this is a Allen key second order bandpass filter. That's to filter out any 50 Hertz on, as far as I know. That comes out there. We've got a precision rectifier, a couple of diodes there, 1N418, 1N4148, sorry. And then I'm not quite sure what's going off here, because this is I think a high pass filter with, I think, about a 500 kilohertz cutoff frequency, so I'm not sure what the crack is there. The output comes out there through this 20k preset, and then that's to read our GM. The bits that I wasn't going to use is, where are we? I've already got a way on my valve tester of measuring anode voltage and anode current. So we've got an op amp here, sets the anode voltage gain, screen grid voltage, and then yeah, blah blah blah, that comes out there, that comes out J13. I won't get into that, it's pretty straightforward. You've got a bit of offset compensation here and a low pass filter. And then here is our oscillator. It's a wine bridge oscillator. These 2 diodes here set in sort of opposite parallel. They control the gain, I think. Now then, there's, yeah. See here, this is version 2. All I've got on my board is a 5K6. Peter says it works better with a 39K in parallel with that. So that's one thing I need to do on my board. Yeah, blah blah blah, and that comes out there. That sets the modulation output level. Well, it just sets the output level of the oscillator, I think. Then we've got a buffer, op amp buffer there. That's that big 1U cap that I mentioned that I had trouble getting in. That comes out there. So pretty straightforward. And then down here we've got all the coupling. After like trying to figure out how to do the 9k 1 resistor, I can bloody see it here, look. 9k 1 can be made from 10k in parallel with 100k. So it already told me there. So it's the same old thing. Read the frigging schematic, read the frigging manual. Right, there's just about everything on the board apart from the op amps. As you see, I've had to be a bit creative with a couple. Well, I've had to do it on pretty much all of the presets. So yeah, but these two here, the 1k and the 10k, I've had to, so yeah, fettle them in because the footprint of this preset obviously doesn't match the holes on the, you know, on the PCB. They're sort of like that, all in a line but smaller, and that proved a problem because, so I've got loads of presets, loads there, loads there. Have I got the right ones? Have a bollocks. So the ones I had, I've got, are like that. See, where the pins are offset, like in a like in a triangular position. So it would have been good if the footprint had like two, you know, the two versions. So something like 1, 2, 3, and then one there. I think that's something like 2.5 mil. Yeah, but anyway, so what I had to do was use a screwdriver, flatten them down, and then sort of make them, you know, so they were in the middle, as it were. And then, you know, the other ones, as you saw, I just had to sort of put a couple of leads out the top there, one over there, and luckily this is a ground, and the one that this pin should have gone in was a ground, so that worked out just nice. Same with this one here. All I had to do was just put a sort of lead over to there, over to this junction here. Junction? Fuck knows. It's a J something or other. I know it begins with a J. Anyway, on the subject of presets, which is why I brought you here, I have some really lovely ones. I mean, look at this. This is a Contelect, and it is 5k, 20k, 5k, gold plated pins. Look at that, isn't that a beauty? And we've got like a 3 presets there. And like a lot of these other ones, these paint and Bournes trim pot, they're actually wire wound. There's actually a wire wound thing in there, and then this goes along like that bar, travels all the way along the bar. Yeah, some really nice presets, but obviously they won't fit on the footprint. The spectral one there, but it's the same with capacitor. I've got just about every value going from 20R, 500R up to like 3 meg. But you know, I've probably only got one 10k, one 1k. I mean, look how they used to make these things in the old days. They probably still do. This is a Morganite, and that is a, well, that's a 10k. As you can see, it's probably been used, but somebody's saved it. And look at the bar along there. I mean, that is a really sturdy bit of stuff. What are the ones I've got? Oh yeah. Whee, a bugger. So as you can see in this one, you can see the wire wound component going across there. Get that off there. If I screw that, you should be able to see the little thing going along I'm going the right way, I bet I ain't. Yeah, there you go, you see that white bit there, that is travelling along, look. Trying not to jig it about a bit. See, the white thing is travelling. Yeah, amazing bit of engineering. And I've got other ones like, not that one, little ones like that. That's a 500R. And then I've got a couple of little ones like that. I love these ones, but these are only one turn. That's a little, is that a spectral? I don't know if spectral is still going. Yeah, lovely little presets, but again, you know, struggling to actually find the correct ones, but we got there in the end, and that's the main thing. So I'll stop waffling about presets, lovely presets, and then we're just about ready to put the op amps in and give it a test. All I've got to do is solder the actual preamp bases or whatever you call them on properly and clean up all this flux, because I had to piss about a bit with some flux because I made a few mistakes and whatnot. Oh yeah, and then I think there is that 39k resistor which goes in parallel with that one for U5 oscillator buffer, and I think we're about there. Lads and lasses, so onwards.